Well, so who would like to ask questions first? Would you guys like to raise your hand in chat? Or Jeremiah, looks like you're unmuted. Did you have a question?
Yeah. You were mentioning that one of the things you really wish you had known early on was about the acceleration and precession of that system and how you could reduce the inertia of that system during acceleration, I think is what you were saying. Could you clarify a little bit more on that? About what happens when you're accelerating a gyroscope and you're precessing it at the same time, I think is what you were talking about.
Both accelerations, it will lose weight faster. It'll lose angular momentum faster. If I have a gyro rotating at a fixed speed and rotate the machine faster, it will lose. It actually transfers its weight to the center of the machine. And that's why it goes up. None of this Euler stuff, this mathematics they give you, it's just not true.
I got you.
Actually,
that's what I needed clarification on. Thank you. Okay, that's all.
Okay, and then I think Mark Sokol had some questions too, and you had some. Mark was pounding stuff out there in chat.
Oh yeah, I was just thinking there was a couple people who brought up gyroscopic devices like this in the past. And one thing I noticed, I actually built a device similar to that I was showing to you earlier. This uses a 2-axis system where they can move both on the Z 90 degrees, and also they can move on the Y, I guess you'd call that, while it's spinning. Have you ever built a device like this, or have any idea if something like this would
probably
work?
not, Mark, probably not. I've built just about every other conceivable shape and form. But one thing I did find out, and it's going to, sorry, I'm upset you, like, but no gyroscope on its own, no matter how enticed, accelerated, bounced up or down, can deliver thrust. I've discovered that. It doesn't mean to say it can't do it, but on its own, it won't.
What do you mean by on its own? What needs to be added?
If I take a gyroscope, I can accelerate it any way I like, up or down, do what I like. There's no way it will ever give me inertial thrust. Other things have to be done to do it.
What other things?
Well, I've just given you the fact that if you believe it, that the angular momentum can be taken away or altered, and you manipulate the angular momentum, you can get anti-gravity.
Or you can get inertial. You can change the angular momentum to linear momentum, right?
Yes.
Okay, and that
but you
explains
can't do it with
where,
one gyroscope. You've got to
well,
have
think of
two.
it. Think of it this way: what's inside the core of the atom is a whole bunch of gyroscopes, which are
That's
angular
true.
momentum. So if there is a connection between angular momentum and linear momentum, then that's where inertia comes from. When you actually throw a baseball or a cricket ball out there in Europe, you're actually changing the subatomic spins of the particles and energizing them. And that's where your inertia comes from.
Well, the thing that gives the giveaway, Mark, is the thing I thought you personally would have got interested in before I even thought of going on to this thing, was the fact that if you have two accelerations at right angles, it seems to cancel inertia. There's a guy on the website, or the forum I used to be on, and he used to call it dark motion, he called it. And he did purely on gravitational systems. Mine have always been accelerated systems, but he's seen the same thing. And there's absolutely no angular momentum or any kind of mass acceleration between the level. Can you see this thing?
Yeah.
You see what it was? That was the other machine.
That's what's
If I
left of
go
it.
all the way up with that, if I go all the way up with that, that gyro is actually trying to run around there. And that one's trying to do the same. The only thing that stops them is the linkage or the stops. But forgot what I was saying. That's the price of old age. It's murder. Don't get the 84 for it. But
Which setup
think
gave you
if
the
you-
best thrust to weight ratio?
the best I've had.
Yeah.
Well, I've got one that's I've had for a few years that I daren't divulge it. I'll get shot. See, at the end of the day, I discovered I can always get thrust. And I'll tell you, there's very simple ways of doing it. That you do it accidentally, you don't even know you're doing it. But in the end of the day, it's the pulse rate that's going to beat you. My first machine, that one did 16 ounces, but to start with, it was down to about 8 ounces by the time we finished for different reasons. That was done at about 300 revs per minute, which was down on the rotation speed of the device because of the mechanism it did it. It's not obvious how it did it or why it did it. It took me years to find out. But it was only about, say, 300 revs per minute. One pulse, 300 pulses per minute. That is not enough to get you into space. But 5,000 might. So that's what I worked on immediately after I did the Australian test on a machine to do that. It can be done, but it's not easy and it costs a lot of money. I'll have to borrow your NC machine there.
Our CNC machine, yes. We'll show you that later.
Well, I built one of these already on the Murray Seaky and it cost me $9,000 and that was 30 quid, £9,000 about 30 years ago. So I actually got myself a 3D printer to make which did an awful lot of good work for me. Showed you, I made a what do you call it, a model of it, and it's good.
If you have the models, we do have a state-of-the-art CNC machine here at the lab in Jersey, and we can replicate your
Is
devices.
it a mill?
What?
Is it a mill or a lathe?
Oh, it's a mill with a fourth axis.
Oh, okay. Yeah, I was looking for somebody with a Murray Seaky lathe about a foot diameter. It would give me this. It's a special hybrid device to do it, but you can. It follows all the. I showed it to Ron Evans. You know, Ron saw it. These guys were quite tickled pink with what it did, but that was about 30 years ago. So
ours can do, I think, 16 inches on the Y, 20 on the Z, and 30 on the X.
You know, I should mention, I think Ron Evans is actually here today too.
is he?
Yeah. I'm not. Yep, looks like
Old
he's.
friend of mine.
Yeah, and then I think Rob Chambers is as well. Yep, he's here. So yeah, him and Ron are both here. So, okay. Well, let me go next to Mark Fiorentino. Mark, would you like to go, sir?
Yeah, I have a question for Sandy and Mark. What's the highest revolutions per minute you were able to achieve with your machines?
I never tried much more. I've done about 500 revs, but that's about as much as I wanted to go. It was not. I don't think it was necessary to go that fast. But an average of about 350. The first machine was 300. It's just a speed I picked. Within a radial drill that did that. That's why I used it. I've had gyros rotating about 15 and 16,000 revs, bronze ones, but the machine itself, 350.
Yeah, my gyroscopes, they're made in England, actually, and they go about to 10,000 RPM, roughly. They're about, we checked it with an RPM meter. They fluctuate a bit, but they're around 10,000 RPM. I think, what's his name? There's another presenter who's working on this as well. Oh, Mike Gamble. Oh, there he is. Yeah, Mike is also building similar devices.
Thank you.
Talk about the RPM speeds and whatnot.
Okay, so let me see. And let me go to Ross Small next. Ross, I'll ask you to unmute.
Yeah, hey, Sandy.
Hi.
So yeah, you said it perfectly when you said the way to create linear thrust is basically what you're doing is you're converting angular acceleration into linear
Correct.
acceleration, essentially.
Absolutely.
So, well, I have a friend that figured out 3 ways to do it. So he did it with angular acceleration. So only while the machine was accelerating faster and faster and faster and faster, he had a linear tether that stayed linear with the gyro, and it created linear thrust only during acceleration. And then he did it after the gyro was already at a super high speed, and while it was decelerating the same way with the linear tether, slowing it down, it did the same thing. So he was creating linear thrust for acceleration or deceleration, and then he figured out how to do it with acceleration and deceleration in a wave pattern. So is your machine changing speed, or you're staying?
Gyros are changing speed.
Okay, so you are accelerating and decelerating
The
constantly.
first machine, the gyros change speed all the time.
Like, but microscopic.
It's not obvious, but it is.
It's just a teeny bit, right? Just a teeny bit.
It's enough. No, it requires, what happens actually is one gyro accelerates, it loses angular momentum. So the other one actually drags it across off the center line. If you notice my
Okay.
machine, it bends in the middle,
Yeah.
and that's what it does. And as it does this, it pulls it up, and it's you've got virtually an empty bucket at the top, filling up with angular momentum as it comes down.
And you could also think of it like they're 2 separate gyroscopes, and they have a center of gravity in the middle.
Yes, they're joined.
So the center of gravity is what actually is moving linearly.
Yes. But-
Okay, that's exactly what I thought.
I had that machine to start with, and it worked well, and I tidied it up to take it down to see Eric Laithwaite at Imperial College. And I tightened up all the rivets on the frame. If you look at the frame, it's a bit tatty like, but there was rivets in it. I tightened up all the rivets and it stopped working, and I couldn't figure out why. And that's what it was. It was the thing could rock and roll back and forward. When it did that, one gyro could always lift the other one, and away it went.
And last question. So do you use springs to slow it down and speed it up, or there's no springs involved?
No, the shaft actually was, the counterweight was actually this created the spring, because it was the weight of the machine. So as it bent across, it held back again. And
Okay, so that's sort of like storing up, releasing energy.
pretty well, yeah.
Yeah.
As one went slower, the slow one is the active one. As you
Yeah.
speed one up, the slow one goes downhill, it pulls the other one up. It's actually pulling it up, and it could lose its speed at the top. It'll gain angular momentum as the other one gets dragged back by the spring as it gains speed. And it works.
If you geometrically trace this on paper, you can actually see that you're right. The center of gravity moves straight while the others would move in space.
It took about 12 years for us to figure this out. When it went to Dundee University, there's a guy there, Bill Ferrier. He's an expert in 3D laser holography. And he died before he got in there. So I never used it. If they'd gone in there, it'd been all over and done with a week it went in. But because we'd have seen what I was doing. But you can't. Very hard. See, I got this thing out basically to show you if I have this running, you can see it, and it's level, you could never ever tell what the angular momentum in there is, because you don't know what the speed of the gyroscopes are. It's altering all the time. And it's only when it goes, it all goes, that's when it starts to go uphill. That's what precession is. There's no angular momentum left to hold it down, no centrifugal force left. It's that simple, but that's not what they tell you. That's not what Mr. Euler said. So really, I can say, because I'm not a professional, that Newton's laws are bunk.
Oh, yeah, definitely, for sure. I mean, it just took people creative enough to figure out.
Yeah, I can
how
say
to
it.
do
I'm not a
it.
professor. I wouldn't lose my job, but
Well,
I can
that's
prove it. I
actually
can
what,
prove it anytime you like.
that's what we've
Because Mark was
needed.
on about it.
Yeah.
He's the guy. He'll prove it.
Yeah, we've needed people that are just down to earth guys that just do it. That just get their hands dirty. They don't sit on chalkboards all day. They actually get out there in the garage and work.
The unfortunate thing was that the machine that went through the lab test in Australia worked for a totally different set of reasons. And that was what threw me. Both gyros went in and out at the same time, but it still delivered and it gave me the lab test. But Strachan's machine was the same, but as Ron Evans will tell you, Strachan's machine vibrated like hell. It was very hard to discern what it was actually doing, but it was built on the same principle.
Yeah, I think you're right. You're going to have to get it up to some really higher RPMs one day. Build it stronger.
No, I think a wee bit cunning design will do a lot better than that.
Yeah, you got to build it really strong, like outrageously strong, and then.
I don't think so. I think you can be clever. There's other ways. I mean, you're just assuming it's a gyroscope. What does a gyroscope do? Find out what it does and alter it.
Well, it's great. You're one of the most. You're one of the guys that everyone follows in this area. So.
Oh well, I had to get on here before I snuffed it.
Okay. Well, thanks again, Ross. So, so let me ask who else has questions for Sandy. And would you guys like to raise your hand in chat, or I see a bunch of discussions in chat, but I'm not sure who else actually has questions. Okay. Jeremiah, let me go to Jeremiah and then William Gregory after that.
Yeah, one last question. And that is thinking about the fundamental effect that's going on here, where you're taking advantage of shifting your center of mass and losing angular momentum, or you're able to precess much more easily as a result of the angular momentum stored along a certain axis. And I'm assuming that only works along that axis. You couldn't say, move it forwards and backwards. If it was a disk, you couldn't say gain any advantage if it was already spinning by moving it like this.
No, none.
Or by moving it like this. But if you try to move it like this,
it's got to be twisted.
It's an advantage, right? You get an advantage basically when you rotate it like this. Yeah. But along any other axes like this or like this, you don't get any advantage.
Do nothing.
Okay, so that was the big secret that needed to be defined and clarified. I think I just wanted to verify with a physical example, so my brain can grasp it because I'm a visual learner in that sense. Well, I guess a lot of people think they're visual learners. Whatever. Thanks. That really helps. That really helps me understand what's going on here and how to take advantage of this effect. So what I really wanted to ask you is, gyroscopes are a physical demonstration that we can see with our eyes, and they're great for the principle to be, shown. But atomically, we should be able to do this solid state with making individual atoms precess, or electron valences precess, or doing something else that doesn't require the physical motion of gyroscopes. Even say, Ron Kita has a patent about a material that happens to have these chiral molecules that have well, they're almost superconducting gyroscopes. They're little chains of charge that are bound together, and they can just keep on rotating around these clusters of atoms in free space, and they can do so uninterrupted. So there's another way of maybe we could do it with a solid state material, and we wouldn't need gyroscopes. We wouldn't need moving parts or arms or mechanics or anything. What do you think about that?
I think it could be done electrically, but I'm a mechanical engineer. I'm a tool maker. That's my limit.
Well, I hear you. But thinking of what you've started, and then imagining what you've done here 100 years into the future, would you like to see it become a solid state device that has no parts that can ever break down?
That's quite a question. I maybe like to see it, but what is required to do it?
That is the question, indeed, for the engineer to figure this out and play around with materials and spend.
I see people with little things flying around, and unfortunately they're attached to the ground. I worry. If the power plant is in the unit that's going up, then okay, I'll consider it. But I think I saw Mr. Ventura there the other night there discussing with somebody, and he was very unhappy about a tether on the bottom of the device.
Yeah, and I can't say that I'm particularly a fan of it either, but I understand the necessity for it in the design. And even
that's okay.
I don't have a better solution for you, so I'm not going to say anything bad about it. And I don't know what else to tell you as far as what you could use instead. So until such time as I have a solution.
Well,
Yeah.
you see, I used to use motors, little oily, smoky, lovely glow plug engines. And they messed up everything. The belts were continually covered in oil. So when I came back from Australia, I thought, well, from now on, it's going to be electrical and it's going to be radio control. And that's the way I've gone ever since. And it's a lot easier, but you can put a LiPo battery on it, away you go. I mean, no problem. I couldn't do that then.
And come on, David Mathis, of course you can do it with no moving parts. NMR, EPR, and DNO already are 3 examples of doing that. So yeah, definitely possible. We just have to figure out how to do it the right way and how we, exactly what motions need to be made and how we can slow down and speed up the amount of energy stored in the valence bands. So there are ways, there are ways to do that. You add photons and you're going to increase the energy of the electron valence band, especially if it's storing, partial energy of a photon and it hasn't released the next one. Theoretically, energy state should be higher. So everybody wants to argue about its quantization level, and there are these substates too between transition bands. So something we need to consider. That is energy that we can utilize, and it should change the precessional momentum of an atom's electron valence cloud. So I think it's possible. I do. I think it's totally possible.
Well, let me.
Too deep for me, boys.
Oh, thanks. I'm sorry. I'm done.
Oh yeah, so let me go to William Gregory, and we're ahead of schedule. So maybe like next week, maybe I'll sneak in with a UAP update again if you guys were open to it. But let me go to William Gregory first, sir. Oh,
okay, I'm unmuted now. Okay, hey, great presentation. I'm really enjoying this. This is more my speed. I'm not a scientist. I'll make that statement again. I make a lot of mistakes, but everybody's so good to explain to me where I went wrong, and I learn a lot because to fail, I wrote a little note here, to fail is really like the back door to success. So one of the things I did, I put a motor in the center of the device, and I put 2 motors on each side of that motor with a cross member connecting them. And so I turned on the disk. It sort of looks like your machine, the reason I'm bringing this up. And so they were all spinning the same direction, clockwise. Let's say they're all spinning clockwise, and the outside disk had an angle of about 45 degrees, or not even quite 40, about 30 degrees. And as I spun the center motor faster, the only thing that happened was my 2 outside motors spinning those discs on the outside, they just flattened out. So it just became like like one disc in the same plane. So I had all these ideas of, like I said, I'm not a scientist, so some of these ideas might be well, they're just theoretical. We'll put it that way. Is that when the disk is spinning in towards the axis of the main axis, the particles on the disk, on that side of the disk, are actually moving. Seems like they're moving slower as compared to the particles on the other half of the disk that are on the outside of the orbit on that disk. There's a lot of ways you can spin those disks. You can spin one clockwise, one counterclockwise, both of them clockwise, all 3 of them clockwise. Do you have anything that you could give me to help me find whether they should all spin the same way, or the center disk, the center motor should spin the opposite way? What do you think?
Everything I've done, the gyro has always rotated, looking from the outside in the same direction. Like if the device is rotating anti-clockwise, the gyros will rotate anti-clockwise from the outside. That forces the gyro to precess or try to turn the torque up the way. If you do it the other way, it'll just get heavier, or appear to. They do the same if you're clockwise, the other one's clockwise, but they've all got to be in the same relative direction. Every device, every gyro on the outside of the rim will have to spin the same way from looking from the outside.
Oh, okay.
Oh, that may be wrong. That's the way I see it.
Okay, and then one other question. Since you've been doing this a long, long time, I'm sure you've probably run across this, because this is what I'm sort of working on at this particular time, is static unbalance on a wheel. If you have a wheel spinning and you have a static unbalance on it, that wants the disc to just pull right out of its housing because it's wobbling. And so my thought was, instead of having a static unbalance, if you could have a dynamic unbalance where somehow you could put weight on the outside of that spinning disc just momentarily, like for 180 degrees, or what they call 1 pi radian, and then make that weight disappear either by temperature change, in other words, making the weight appear and disappear on every half rotation. And then it would sort of, instead of wobbling, you'd get this effect that in free space, it would want to do like a chop wave or a cup wave acceleration. Have you know what I'm talking about a static unbalance? Instead of having a static unbalance, have a dynamic unbalance without violating Newton's third law.
Forget that one. Go nowhere.
Well, I do have a workaround Newton's third law on that particular one, because to me, and I've got into arguments about this, about acceleration being a one-way street. Gravity is a one-way street. So if you could move a mass inside the spinning disk using only acceleration, could you possibly beat that equal and opposite reaction, Newton's third law?
To try it.
Does anybody want an answer to the mechanical, how to get past these imbalances? In terms of, it's very, if you want to proceed without wasting much time, when you spin a drum of water, it self-balances. Are you with me?
Yes.
There are a whole bunch of fluidic devices that run off of spinning fluids. And when you have, I'll give you an example. If you were to momentarily, we all know the specific gravity of water is 1. And if you have an ice cube, which is for all practical purposes, specific gravity is 1. If you throw it into a drum of spinning water, the drum will self-balance. Are you with me?
Yes.
If you pull the ice cube out quickly, it goes back into balance again. So what it is, the whole thing is to work with spinning fluids, have the eccentric match the specific gravity of the fluid. Pull it in and out. You can do it with a solenoid or anything. It will self-balance. And what happens is there's an equal and opposite reaction to the center axis of the thing that self-balances. And so in terms of dealing with mechanical things that can break, you have a very smooth running device. The only requirement is to put a mass into the fluid. As soon as you put the mass into the fluid with the same specific gravity, the dynamic does not recognize the material because it's of the same specific gravity. Then you pull it out, it goes into dynamic balance, and if you get 2 of them together, clockwise and counterclockwise, you will get linear propulsion. That's it. So I'm out for the day, I think. So in terms of, but at the gyroscopes.com, there are a whole bunch of fluidic devices. A lot of them do not use the same specific gravity of the rotor, but they use, you can use a fluid, but the combination of a solid and a self-balancing liquid will give you propulsion if you want to go to mechanical things. But that's all. So enjoy the day, guys.
Hey, thank you, Ron.
Doesn't look like Tim's around. Tim?
I don't know if no one else has a question for Remi, real quick. I do have one more question for him. Would you be interested in working with us to try and take some of your concepts and experimentally test them? Because our expertise is mainly focused in turning ideas into experiments so that we can check some of these interesting theories to see if there's something to them, since they might just be, you know, the new revolutionary physics we need to get to space with very little energy. So if, you know, would you be interested if you're still around, Remi?
Oh, were you asking Remi? Remi actually had to leave. Yeah, because it's late UK time.
Yeah, I'll have to get a hold of Remi, because I'm wondering, he's got a lot of interesting ideas and he's saying he's having problems implementing them into experiment, but you know, that's kind of like what we like to do. So.
But you should ask Sandy as well, you know, see.
Well, does Sandy have anything that he'd like us to test that he's having trouble testing himself?
Just prove that Mr. Newton's wrong.
We are trying to do that, but we're trying to do it in a very different way. We're trying to do it.
I'll give you a simple way to do it. Just rotate a mass and put strain gauges on the beam. You'll find out very, very quickly. Angular momentum will disappear. Newton says it doesn't, or Euler said it doesn't.
Yeah, we will have to try that because we do have a beam balance and we do have gyroscopes, so might as well.
Okay.
I'm sorry I goofed with my photographs, but the last machine I showed you was actually the last set was for a machine to go all the way up from zero gyro speed, to go right through the whole motion with strain gauges underneath showing you the losses and centrifugal forces it went. And it was all telemetry. It's been run, it's all telemetry. But you can have that one if you want.
Yeah, that would be the two gyros, you know, almost like in the perfect center position so that you could decelerate them right dead center axes, you know, somehow, instead of having them any other angle. Yeah.
Try the, what I said, the free lunch experiment. And you put that together, you can go into space yourself, no bother.
Okay. Oops, sorry, Jeremy, I didn't mean to mute you out. So I think we're just about all set for now. Sandy, I think that was just about it, right? For Q&A, or?
Yep.
We do have extra time, but I was gonna, well, let me do this then. Let me put it on gallery view, and everyone please give Sandy Kidd an enormous stand.
But don't invite him to do it.
Well, again, thank you for presenting, Sandy. Yeah, it looked like questions had to kind of wound down to nothing. So let me meet you out then. And I guess the first thing I should ask is, we do have Mike Gamble scheduled for 4. I do have a UAP presentation that I can do. We have Frank Milburn who joined us as well. I guess the question is, would you guys like Mike? Let's ask Mike if he would like to go now. Mike, would you like to present now, or would you like me to do a brief UAP thing first?
Go right ahead. I'm interested in watching the UAP.
Oh, okay. If you're up for it, I just didn't want to.
No problem. If you want, I can go right now, but I'd just soon watch the UAP.
Okay. I just didn't want to be disrespectful at all. Well, let me do that then. And we do have Frank in the house, and I will pester him for updates as well. Here, let me launch my presentation then.